These are the notes for section 4.4, day 1 in calculus. Remember, chapter 4 is all about applications of derivatives, so we are going to use our derivatives quite a bit today. First, we are talking about questions that concern related rates and how to solve these. I would recommend pausing the video at this time if you want to write down this list. First thing you're going to do is draw a picture. If possible, you got to come up with two equations, solve one to plug into the other, find the derivative, set it equal to 0, and solve. Alright? Then answer the question. So, our first example, what is the largest possible area for a right triangle whose hypotenuse is 5 centimeters long, and what are its dimensions? So if I draw a right triangle, and I label it, it says the hypotenuse is 5 centimeters long. So that's the side I know. I don't know x, and I don't know y. Okay, so now I have to come up with, wants to know what are its dimensions, what's the largest possible area. So, in my thought process, I need to come up with two equations. First is area of a triangle. I know area of a triangle equals 1/2 my base, which is y, times my height, x. The second thing I want to think about is what else do I know about right triangles? Well, my best example is Pythagorean theorem. So I know x squared plus y squared equals 25. Okay? So now I gotta take one example and I need to solve it for x or y. Depends on the equation you want to use. It's simpler to solve our Pythagorean theorem, so I'm going to take away x squared from both sides. Y squared equals 25 minus x squared. And I square root. And y equals the square root of 25 minus x squared. So now I have y. Now I'm going to take that whole thing this whole part, and it's going to get plugged in here for y. So now my area formula becomes 1/2 x times the square root of 25 minus x squared. And now I got to find the derivative of that. When I'm finding my derivatives, remember I have a product rule going on here. So I have a u and a v. So u equals 1/2 x, du is 1/2, v equals 25 minus x squared to the 1/2 power, so dv is a chain rule. Do my chain rule, I do the derivative of the outside, so bring down the 1/2, take away 1, times the derivative of the inside, which is the negative 2x. If I simplify that guy, I'm going to get negative x times 25 minus x squared to the negative 1/2. And now, I need to actually find a prime. So our steps started off with draw your picture, come up with your two equations, which we've done, and then find the derivative of the one that you were able to plug into. If I slide over, I get a prime equals 1/2 x times this, using the product rule. Now I need to start doing some simplifying. So here I'm going to have negative x squared over 2 square roots of 25 minus x squared plus the square root of 25 minus x squared over 2. I'm going to find a common denominator. So I need to multiply this guy by the square root of 25 minus x squared over the square root of 25 minus x squared. So I end up with negative x squared. Here my square root's going to cancel out. Plus 25 minus x squared over 2 square roots 25 minus x squared. Okay, so now we found our derivative, we've simplified. Now we got to set that guy equal to 0 because the question asks for the largest possible area. So I'm looking for a maximum, and maximums occur when the derivative is 0. So here's my derivative. I set it equal to 0. And in doing so, I'm going to end up multiplying 0 by the denominator to get rid of that in the denominator. So I just get left with 25 minus 2x squared. Add my 2x squared to both sides. Divide by 2. And x equals the square root of 25 over 2. Right now, normally when we have a square root, we get a positive and a negative value. Since we are talking about a distance, it must be positive. So x is the square root of 25 over 2. So if x is square root of 25 over 2, we can now solve for y. Okay, we go back to our Pythagorean theorem, and instead of x, we're going to put the square root of 25 over 2 squared plus y squared equals 25. If I square this guy, I get 25 over 2 plus y squared, which is 25. Take away from both sides. 25 over 2, so y is also the square root of 25 over 2. Now that I have x and y, we need to go back to the question and figure out what we're talking about. The question asks us for the largest possible area, so we now have to plug everything back into our area question and figure that out, because we've already found the dimensions. So we know area equals 1/2 times the square root of 25 over 2 times the square root 25 over 2, which is going to end up with 25 over 4. Let your calculator do that. Now it tells me that this is given in centimeters, so this is centimeters squared. You can also label your y in centimeters and your x in centimeters. Yes, what are its dimensions? Now if we're talking in terms of an AP question, in order to answer the question we would have to say the maximum area occurs when x and y equal the square root of 25 over 2 centimeters and the area is 25 over 4 centimeters squared. Let's go on to the next example. Example 2. Show that among all rectangles with an 8-meter perimeter, the one with the largest area is a square. So first thing we need to do is draw our picture. So I draw a rectangle. I have side length x, side length y, because I don't know what they are. All I know is my perimeter has to equal 8. Alright, so I know, based on perimeter, that 2x plus 2y has to equal 8. I also know that for area of my rectangle, because it's talking about the largest area, alright, then my other formula would be A equals x times y. And since area is what I'm looking for, and I have values here on the left for perimeter, I'm going to solve that for x or y. In this case, we'll solve for y again. So I take away 2x from both sides, I get 2y equals 8 minus 2x, divide everybody by 2, and I got y equals 4 minus x. So that is what I'm going to plug in up here for y. So now I have my area in terms of x. So I end up with a function a equals x times 4 minus x. And it's up to you if you want to go ahead and distribute this out. It does make finding the derivative a little easier. So I get 4x minus x squared. If I find a prime, that's going to equal 4 minus 2x. And remember, we're now setting this guy equal to 0, because we're finding a largest area. So 0 equals 4 minus 2x. Negative 4 equals negative 2x. So I get x equals 2. So my perimeter is going to occur my perimeter equals 8, then my max area is going to happen when x equals 2. So now I got to find my y. Back here it says show that among all these rectangles, the one with the largest area is a square. Remember, on a square, x and y have to be the same. So that's what I'm trying to prove. So I go back. If I know x is 2, I get y equals 4 minus 2, which makes y equal to 2. And therefore, when we go to write our question, we state that the maximum area occurs when x equals 2 and therefore y equals 2. Since these are the same, the shape must be a square. So we've shown that among all rectangles with an 8-meter perimeter, the one with the largest area is a square. Moving on to the next example. You are planning to close off a corner of the first quadrant with a line segment 20 units long running from A, 0 to 0B. Show that the area of the triangle enclosed by the segments is largest when A equals B. So we gotta draw a picture. Remember, they're talking to us about quadrants. So here is my coordinate plane. I'm closing off the first quadrant. So my picture is going to look something like this. Show that the area of the triangle enclosed by a segment is largest when A equals B. Now I know that my hypotenuse is 20. I also know that this is a right triangle because it's closing off a quadrant and my coordinate plane crosses at a 90-degree angle. I'm back to having two formulas that I can use because I have a right triangle. We have our area, 1/2 b times a. Now notice, I say b times a because this distance from here to here is a, and the distance from here to here is going to be b. So my base is a, my other leg is b, my hypotenuse is 20. So area is 1/2 b times a. Then I also have my Pythagorean theorem. So a squared plus b squared equals 20 squared. And now I need to solve one of these guys for the other variable. Once again, much easier because I have the 20 in my Pythagorean theorem. I'm going to solve that for a or b. If we go ahead and solve for a, we're going to get a equals the square root of 400 minus b squared. 20 squared is 400. If I subtract my b squared to the other side, take the square root, then I get a. So the area equals 1/2 times the square root of 400 minus b squared times b. Okay, we are back to finding the derivative, a prime. And I'm going to have a chain rule, so u is 1/2 b, v is 400 minus b squared to the 1/2. So du is 1/2, dv is 1/2 times 400 minus b squared to the negative 1/2 times 2b, negative 2b. So my 2's are going to cancel again if we continue to multiply, and then we use our product rule. We end up with negative b squared over 2 square roots 400 minus b squared plus the square root of 400 minus b squared over 2. Remember, we need to do common denominators, so we're going to multiply this guy by 400 minus b squared because that's what we don't have. Negative a prime equals negative b squared plus 400 minus b squared over 2 square roots of 400 minus b squared. My numerator is going to simplify to negative 2b squared plus 400 over 2 square roots of 400 minus b squared. So now I have to set that guy equal to 0. So if that equals 0, and I multiply both sides by the denominator, I end up with negative 2b squared plus 400 equals 0. Add your 2b squared to the other side. Divide. So b is the square root of 200. If b is the square root of 200, remember from up here, a is the square root of 400 minus b squared. So a is the square root of 400 minus the square root of 200 squared, which makes a equal to the square root of 200, which is not a perfect square, so we leave it as a is the square root of 200, b is the square root of 200. Well, the question asks us, show that the area of the triangle enclosed by the segments is largest when a equals b. Did we end up with a equals b? Yes, we did. Both of these equaled 200, so we proved that a equals b. Alright, next question. A 216 meter squared rectangular pea patch is being enclosed by a fence and divided into 2 equal parts by another fence parallel to one of the sides. What dimensions for the outer rectangle will require the smallest total length of fence, and how much fence will be needed? So, I have a rectangle, and I have a fence in the middle, because I'm cutting this guy in half. Now it tells me it's the whole thing needs to be divided into 2 equal parts. So, if this is x, and the whole thing is 216, then this side is 216 divided by x. Okay? So my area, I'm told, is 216, which means that need a second equation, which is my perimeter. Perimeter is going to be 2x plus 2 times 216 over x plus another x. Now why do we add the other x? We add the other x because of this length right here. I'm putting a fence in between my 2 parts, so I got to include that guy. So my perimeter is 3x plus 432 over x. And that is what I'm going to try to figure out the derivative of. So p prime is 3 plus negative 432x to the negative 2, which is the same as 3 minus 432 over x squared. Now I want to set this guy equal to 0. So I get 0 equals 3 minus 432 over x squared. Move my 3 to the other side. Multiply both sides by x squared. Divide by negative 3. And square root, so x equals 12. So, each of the parts of the fence, this is 12, this is 12, this is 12. Then this side is 216 divided by x, which is 18. So let's answer the question. What dimensions for the outer rectangle will require the smallest total length of fence? Well, the outer rectangle should be 12 by 12 meters, and we will need blank number of fence. We don't know how much fence we need yet, so we gotta add this all up. I have 2 sections of 18, and I have 3 sections of 12, so 36, and 36 is 72 meters of fence. Okay. You can go back to your perimeter and plug in 12 for each of your x's if you'd like, and that'll give you the same value. Your homework is page 226, 1 through 9 odds. We are going to work through those in class. We'll probably try to do one together in class and then give you some time to work.